Okay, kids, we're back with the last installment of the normal model kind of capstone problems where we've mastered finding area and using area to find cutoffs. And now we're going to look at an application problem of that. So here we have men's shirt sizes at a clothing store called Podunk Republic are determined by their neck sizes. Suppose that men's neck sizes are normally distributed with a mean of 15.75 inches and a standard deviation of 0.72 inches. Executives at Podunk Republic have determined that 17.2 inches will be the largest neck size for a size large shirt, and that exactly 30% of men's neck sizes will fit a size large shirt. Now, if this is the largest size large, we want to know what's the smallest neck size that will fit a size large shirt. So I'll let you process that for a second. So really, what we're on is we're on this t-shirt curve. And on this t-shirt curve, we have extra small and medium and large and extra large and 2X and husky and all the sizes that you can think of under the sun. We're told that it's approximately normal. And we're told that the mean is 15.75 and the standard deviation is 0.72. So here's our shirt curve. And we want to know, we know that 30% of men's will fit, and their cutoff is 17.2 will be the largest, right? So we know that we're going to have some size here, 17.2, which is bigger than 15.75. So we're right at the mean. And we're going to have some other cutoff somewhere over here so that this is 30%. And we want to know what is this value. We're trying to find that. Okay, so this is 30%. Here's mediums, here's smalls, etc. Right? So what we're going to do is take an approach where we're going to use area in one way or the other that we know. So I know that I have this normal curve, and I know that I have this cutoff. Before I continue with the solution, you should pause it and try it on your own if you haven't done that yet, or if you're watching it for a refresher. Here we go. We can do one of two things. We can find the area all the way to the right of the curve, normal CDF from 17.2 to 9999 with this mean and this standard deviation. And then we can go back and we can add in this orange 30%. So I'm going to do that. I'm going to say, all right, I'm going to first find a z-score from 17.2 minus the mean divided by 0.72. So and I got 2.0139. So that's how many standard deviations above the mean of 15.75, 17.2 is, right? So we're really probably further out here. Then I'm going to find the area, the probability that X would be greater than 17.2. I'm finding this yellow area. So greater than 17.2. So I want to know how much is it from here to the end. So I'm going to do normal CDF. My lower is 17.2. My upper is 99999999999, the biggest neck you can ever imagine. My mean is 15.75. My standard deviation is 0.72. I hit paste, and I got this probability to be 0.02201, blah, 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 blah. Okay? Now, that's this. This is 0.022. This is supposed to be 30%. So I'm going to combine those, and I'm going to say, all right, well, this plus the 30% that's size large is going to give me 0.32201, etc. Right? That's from this cutoff all the way to the right, forever and ever and ever. From this cutoff to the right is this area. So I'm going to use this is my the upper 32% of the curve, right? So I'm going to do inverse normal if I have minus that. That means that everything on the other side is going to be 0.678 ish if I round. So I got this cutoff is the 67.8 percentile, really. So we're going to do inverse normal. I'm going to set up a z-score equation. Z equals, I don't know x, but the mean is 15.75. The standard deviation is 0.72. And I'm going to find the z-score for how many standard deviations away from the mean this cutoff is if I'm looking at the top 32, like 0.322, or the bottom 0.678. So inverse normal on the mean is 0 and the standard deviation is 1, and I'm putting in 0.32201, and I get back 0.462. That's the z-score. That's how many standard deviations away this x is from the mean. Not quite 1. Not quite a half, really. So I'm going to multiply by 0.72. I'm going to add 15.75, and I got x is 16.0827 if I don't round. So that's the cutoff for the smallest next size. This is in inches. We're going to remember units when we're looking up x or mu or sigma. So we have inches, and this is how we did it. Now that's one way to do it. We could have also found the area all the way to the left of this number. So let me show you that. This is just a bonus, like extra approach. I have that work right here. So what we could have done is started with our curve, found the area all the way to the left, this big area. There's the area all the way to the left, and then subtracted 30%. So we're left with just this 0.678 that we already found once, right? And so I can do it that way too. I can go from this cutoff left and then subtract 0.3, or we could do what we just did and go from the cutoff right and then add 0.3. But either way, we're going to do that to look up that percentile or that area to the other side to be able to find that cutoff. Okay, so hopefully that helps you. Good luck in completing your rest of your homework.